Alright, so let's begin with a new ensemble, and I'll create a macro that's going to hold an array of send objects, which you can find in the terminal menu. The sends are basically going to act as the heart of our ensemble, so every macro with an audio output is going to flow into a send object here, and we'll use a bunch of receive modules to route these signals where we want them to go. So I've got 32 sends in our first macro here, and I'm actually going to duplicate this macro so that we can have a total of 64 sends. I'm going to put these all inside of another macro just to keep things in the main ensemble view a little bit cleaner. So our modular synth is going to consist of a bunch of sound sources and modifiers that flow into these send modules. And then we'll have a matrix of receive objects that can receive those audio signals and route them in any way that the end user desires. So in order to do this, I want to create a couple of macros that are going to help us to interface with the send-receive matrix. One of the macros will interface with the send modules, the other one will interface with the receive macros. So I'm going to create the send macro first, and basically it has a very simple task, which is when you press a button, it simply outputs the ID number for that send. So in order to create the button, I'm actually just going to use a mouse area with its size set to 16 by 16. And we'll connect it to a separator module so that whenever we press the left button on the mouse area, we'll trigger the ID value for the send. So this macro will receive the ID value as an input, add one to it, and from there it can flow directly into a value module that will be triggered by the separator. And it will also flow to the output of the macro, and this way we can chain our send macros together, so we can connect the ID output of this send macro to the next one, and it'll keep track of the ID for us in a very simple manner. We don't have to create a different value for each one, and it's just a lot simpler than creating a different constant value for each send module. So then we'll create an output connected to the value module, and that'll be our active send number. So we'll create a similar macro for the receive modules, and whenever the button in the receive module is pressed, that receive will be connected to the currently active send value. So let's create a macro for our receive and name it appropriately. And as before, we're going to want to create a ID input to tell us what the ID of this receive is. Each one will have its own unique number. We also need to know what the active send is. And finally, we need to know how many sends are in our project in total. So I'm using this input instead of just creating a constant value of 64, just in case we decide later that we want to have even more sends, or if we decide we want to have less. Makes it a lot easier to change. And once again, I'll be using the mouse area as sort of a button, and we'll be using both the BL and BR outputs from this in order to trigger different events. So if we press the left button, we're going to connect to the active send, whatever the active send currently is. And if we click the right button, we want to disconnect from any connections that are made with this receive module. So if we are disconnecting, we're just going to trigger a value of 0. And if we're connecting, we're going to trigger a value that's equal to the active send number. And both these values are going to the same place, so we can use a merge module to merge them together. And we'll flow the output of that into a snap value. So the snap value is just going to hold whatever value we have coming out of this merge here, so that when we save a snapshot, the value can be recalled later. And this is really important for, making a modular synth that's actually worth anything to the end user, making sure that the presets will recall correctly. Now, we're going to use the output of this snap value array, which is telling us which send module we want to be connected to. The value of 0 means we're not connected to anything. And we're going to use this number to control a receive module, which is kind of weird and clunky. We need to interface it using an IC send object. And the IC send is going to get a value from 0 to 1. So this next little bit of math here, to be honest, it's something I just kludged together through trial and error. It took a while. It was kind of annoying, but it works. So I'm not going to question it. And the one instance in which it doesn't work is if the snap value is equal to 0, in which case we want to set the output of our math here to 0 as well. So I'm going to use a compare module and compare to 0. If it's anything but 0, then we'll multiply by 1. If it's equal to 0, then we'll multiply by 0. Finally, the output of our math here is going to be connected to an IC send. And we'll use the IC send to control a receive module remotely. The receive also needs to be set to 0 in case the snap value is set to 0. You can get some weird artifacts if you don't do this. So make sure we set the enable switch off in the receive module, which lets us disconnect from any connected send module. And then in the Connect tab of Properties, connect the IC send to the receive module. So now whenever the IC send receives a value, it'll change the connection of the receive module appropriately. Alright, so finally I want to add a simple ID system so we can identify elsewhere which receive modules are connected to which send modules. So in order to do this, I'm simply going to take our incoming ID and add 1 to it, as we did before. And then that value can be output from this macro to be directly fed into the next receive macro that we create. And we also want to trigger that value whenever we receive a button press on our mouse area. So I'll send it into this value array here to get triggered on a left button press. And if we receive a right button press, that means we want to disconnect this receive module from any sends that it happens to be connected to. And in order to denote the difference between connecting this ID to something and disconnecting it from something, I'm just going to invert the value, so the value is negative if we're disconnecting and positive if we're connecting. And so these outputs are going to be used later on down the line to control our graphic interface that will be showing lines in between connected modules to give you an easy and quick idea of what's connected to what. Alright, so that's about it for the send and receive macros that we need to make. I just want to take a moment to test the receive macro before we go about designing a GUI. And in order to do that, we just need to set the number of sends to 64, the number of send modules in our project here. And then I'm going to use a knob to control the active input. So whenever we press the mouse area in the receive macro, we should set the receive module to whatever number is determined by the active knob. So we'll have the active knob range from 0 to 64. And let's hop to the panel view. We need to make a few changes still. The mouse area is going to be invisible if we lock the panel, for example. So we want to change that. We also want to set the receive module to be visible so we can tell that everything's working properly. And I'm going to give it a larger width and change the style to a menu. And yeah, with the mouse area you can just set the transparency to something less than 100%. We should be able to get a look at it. We also need to change the outline style. And so when I'm clicking on the mouse area, I'm not getting any response. And it's probably because everything's polyphonic inside our receive macro, which I forgot about. We also need to set it to be always active. So I'm going to connect the output of the macro to a numeric module, set that to always active, and then we can set the entire macro itself to be monophonic. And at this point in time, things should work. Make the numeric value invisible here. Alright, so when I press on the mouse button now, we're actually still getting some weird input here where the value that is being entered into the receive module looks like it's 32 higher than it should be. I think this is actually because our send modules are misnamed though. So if we hop into here, we see that they're actually named from 33 to 96 instead of from 1 to 64. So that's why that appears to be a problem, but everything's actually working just fine at the moment. And we can show that for sure just by renaming all the send modules, which I'll do off screen so you guys don't have to watch the tedium of that. Alright, so I've done some purely cosmetic rearranging here. I've made it so the send modules are a solid square and the receives are an empty rectangle so we can tell them apart. And I've also renamed all of the send modules so that you can tell that we're connecting to the correct send when we click on the receive. And that seems to be working fine. And so what I want to do next is to create a macro that draws a line between any send module and receive module that are connected to each other. So I'll create a new macro and name it wires. And we'll take the send output from the send macro and the receive output from the receive macro. And these respective outputs are triggered whenever the send or receives are pressed, whenever the mouse area is triggered. In order to draw a line, I'm going to use a multi-display module. And the multi-display is going to be layered beneath all of our send and receive objects. I want to make this very large. I'm going to set it to have a width of 1024 and a height of 768 pixels. And I want to set it so that the range is equal to those numbers as well. So we'll change the X and Y range. We'll be using the multi-display to draw straight lines, so we can set the object type to -2. And I'm going to set the color to be blue. Alright, and we're going to feed the rest of the parameters that we need using a snap value array. So the snap value array is going to accept inputs for x1, y1, x2, y2, and alpha. And so that snap value array here is just preemptively making sure that we'll save the contents of the multi-display when we save a snapshot, and we can recall them as well. Next, we want to have an object for each receive module in our project, in the multi-display and in the snap value array. So I'm going to set the number of objects to 256, which means we can have up to 256 receive modules in this ensemble. Alright, so the next module that I want to create is a mouse area. And we'll set the mouse area to have a size that's equal to the multi-display. So we'll have 1024 by 768 pixels. And we want to turn on the always send px and py events. What that does is it tells the mouse area to send out events even when there's not a button pressed, whenever the mouse is hovering over the mouse area. And we want to store those px and py values in value modules, and we'll keep them there until we receive an event from the send or receive inputs. So first, the send input, we'll just trigger the px and py values and store them in another set of value modules. So this is just saving the mouse position wherever the mouse was when we pressed the send button. And when we get an event at the receive input, we'll end up triggering all of these value modules. They'll store the position of our mouse when we pressed the send button, and another set of value modules will store the current mouse position. So we'll draw from the send point to the currently pressed button. So those then become the x and y inputs for our snap value array. And again, we want to trigger them using the receive input. There's a lot of stuff we want to do with the receive input, however, so we're going to need to create an order module first. And remember that the receive input can be either a positive or negative value. If it's positive, that means we're connecting that ID number, and if it's negative, it means we're disconnecting the absolute value of that number. So we'll use a rectify to determine the ID of the incoming receive number. And the output of that is the index of our snap value array and our multi-display. So we can feed the output from there into the index input. And we want to trigger the value modules as well here. So this is the reason why we bothered to give our receive modules their own index number earlier. It makes it so that we can declare a separate object for each receive module in our multi-display. And finally, we want to set the alpha value to be 1 if we're turning the connection on, and we want to set it to 0 if we're turning the connection off. So we'll use another rectify sign, and the output will either be -1 or 1. So I'm going to add 1 to that value. So now we'll have a value that's either 0 or 2, and then we'll multiply the output by 0.5, giving us a value that's either 0 or 1. So it'll be equal to 0 if the incoming number was negative, and it'll be equal to 1 otherwise. And we can run that into the alpha input of the snap value array. Alright, so let's set the multi-display to be always active in the function tab of properties. And we want to set everything else to be monophonic. And I think we're just about ready to test things. So let's hop to the panel view. And I'm going to load a background picture for the multi-display in the background bitmap menu here. And I just have a file I use for this sort of stuff called alpha. It's a 600 by 800 empty image, and then you can use the vertical and horizontal resizing to make the multi-display whatever size you want. So once the multi-display has an invisible background here, I'm going to layer it underneath the mouse area. Alright, so now we can move the send and receive macros anywhere on this mouse area here, and we can create wires between them by clicking on the send and then clicking on the receive. Alright, and so this is working, but it's taking a few clicks on the receive to work, so I've probably made a very simple error in our wire macro. So let's hop back in there. First thing I want to do is make sure that we're using the third output of the order module here to trigger these values. Looks like I screwed up and connected some of them to the second output. And we also want to turn the ignore alpha button in the multi-display off. And so I think that was screwing things up, because if we set one of the objects to have an alpha value of 0, it automatically sets all of the objects to have an alpha of 0. So we need to have that turned off. Alright, so now things seem to be working just fine. Again, we can move the receive module anywhere we want and still draw wires between the two objects. Next, I want to create a macro that encapsulates all of the code we need for a single audio module in our modular synth. So I'm going to create a new macro named template, and I'll copy paste the send and receive macros we've already created. We can get rid of the active knob here, and we want this macro to receive the ID values for the send and receive modules, and also to receive the active send for our receive module. So the active send will be our first input, and we can run it into the ACT input of the receive macro. So we also want to have a output for the send. And the way this will work is we will link our macros up one after another, and each macro will pass some information along to the next macro in line. This will just create some cleaner looking code at the end. And next I want to create a send ID input and a receive ID input. And these values we also want to pass along to the next macro in the chain. So we can create some outputs for those as well. Basically, each macro will take a send ID, and it will add a value of 1 to that for each send in the macro, and then it'll send an output, also called send ID, that will tell the next macro which index to use. So this is just a really simple way to keep all of our sends in order. And we'll do the same thing with the receives. And we also have an output for each that goes to the multi-display macro we were working on earlier that draws the wires. And so these are just telling that macro when we receive an event from either a send or receive macro. And finally, we have one more output that is going to be our audio output. So I'm just going to leave it attached to nothing at this point in time. Presumably we'll use the receive to affect the output in some way. And the last thing we need to add is a picture module, and this is very important, and I'll show you why in a moment. First, I just want to load it up. It's not going to show anything, it's just going to be there in the background. And we'll set the size to the amount of screen space that we want this module to take up. So I'll make it like 128 pixels by like 256 or so. Alright, so the reason why we need the picture is because of the way that Reaktor's image processing works, and we don't really have a very good way to tell Reaktor which images, which modules should take precedent over other modules. So this big mouse area that we have in the background here is really only there to detect the mouse over when we want to draw wires between two modules. So in a sense, we want it to stay beneath all of the audio modules that we add to it. However, a problem arises if the user clicks on the mouse area, then that mouse area gets brought to the top of our image processing, and therefore the mouse areas that we're using for the send and receive macros stop working because there's another mouse area on top of them taking precedence. So this is a really awkward problem, and it's one of the big complaints about Reaktor is that we really kind of need a way to fix this. But for now, what we can do is we can layer a picture that'll stay beneath all of the modules in our audio module, and if we cover the whole space that the mouse area takes up, there will be no way for the user to click on the mouse area. So whichever mouse area has been clicked most recently takes precedence, and you'll see when we click on the larger one, the send and receive modules stop working altogether. I can no longer connect wires between them. And once we've selected the template macro here in the structure view, that'll jump back up to the top again. So again, this is just really awkward, and we want to find a way to work around it the best we can. So by layering a picture beneath all of the relevant information in our template module, we can stop the user from ever selecting the mouse area in the first place. So the wire send and wire receive outputs of each audio module will be sent to the wires macro, and we'll have to merge them all together. Remember, this macro is monophonic, so make sure your merges are as well. And let's just hop to the panel view for a second and make sure that once we've selected our template macro, the sends and receives are working again, and they are. And of course we can break them again just by clicking somewhere on the larger mouse area here, and then now I can no longer use the sends and receives again. So this is just a kind of a strange problem. If your structure stops working all of a sudden, that's what's going on. And the only way to really work around it is for us to cover the whole mouse area with pictures, which we eventually should do. So let's continue by creating some very simple audio modules and turn them into a synth. Say we'll create a envelope and an oscillator and maybe an output to the speakers. So I'm going to connect the audio output from our template into the first send module, the first available send macro module that we have. And the next thing we want to do is we want to get the active send value to feed into the macro. And this is going to come out of our merged send values coming out of this merge module here. And so this will just be the most recently clicked send ID. And we'll take that value and run it out into another macro and feed it back into the input of our synth structure here, and send it into the input of our send of our template macro. And I'll add some inputs so that it has as many inputs as it does outputs, and that'll just make everything line up smoother when we connect a bunch of these together. Alright, so that's kind of our preliminary work that we need to do. And next let's create an oscillator structure here. So I'll just use a saw sync, a triangle sync, and a pulse sync. And we can give the user a switch to choose between them, and just simply run the output of this macro to an audio output that will eventually be sent to the send matrix, and then we'll be able to grab this signal with any receive module in our synth. So just create a simple pitch shifter here. I'll give it an octave knob. Goes from -36 to +36 with a step size of 12. Give it a semitone knob from +11 to -11 semitones. Step size of 1. And so obviously you can just create, however you want to have your oscillator work here. I'm just making something that's very cookie cutter, standard. So we'll have a fine tuning knob, and all of this can run into the pitch inputs, of course. And what I'll do is I'll have the audio receive, the receive macro we have, control the amplitude of these oscillators. So we can just run the output from the receive macro directly into the amplitude inputs of the oscillators. Another option would be to first check if the receive module is turned on and actually receiving a signal. And if it's not, to set the amplitude to a constant value, probably 1. And then that way, if the receive module was connected to nothing, then the oscillators would just be considered to be always on. And that can be useful for certain effects. So I'm just going to keep it really simple for now, however. Let's make sure we actually keep our template module here, and we can create another one. And this one's going to act as our envelope. So we'll receive the active send, the send ID, and the receive ID from the previous macro, and we'll merge the wire send and wire receive outputs in the appropriate place, and we can send the audio output into the send matrix. So let's change the names here to something other than template so we can tell what's what. And creating the envelope macro is going to be very simple. I'm just going to use a really bare bones envelope as an example. We'll have a gate input and a knob for attack, decay, sustain, and release. And that's pretty much all we need for now. We're not even using the receive module at the moment, although that could also be used for a variety of purposes. We could use it to scale the envelope. We could use it to trigger the envelope. We could do all sorts of stuff. So once we have this finished, I just want to create a third template macro here. And this one's going to act as an output to our speakers. So we can duplicate the template macro and give it a name, and the insides are going to be pretty simple for now. Again, I'm just keeping these all incredibly bare bones, but they should all be expanded upon greatly. You can make them a lot more powerful than what I'm doing now and give them a lot more flexibility. But for now, we're just going to run the receive directly into the output of our macro and directly into the speakers. And we can also connect it to the send matrix and use it as a feedback source for any receive module in the synth. Again, we'll connect the WS and WR outputs. So now we have our three macros. This is pretty much the bare minimum modular synth here. We've got our an envelope, an oscillator, and an audio output. And I'm not going to make you watch me rearrange all of this mess, but here's what it looks like once we untangle everything. And I tried to link those all up, and I noticed that something wasn't working properly. And so what it was is this multiply right here in our receive macro was set to be monophonic, and it needs to be polyphonic. So I set it to poly, and now everything is working fine. So you need to find all the instances of that, and also make sure to change it in the template macro so you don't keep copying your error into new modules. Alright, so now we can control the amplitude of our oscillators with the envelope and run the oscillators into the audio output. And when we play notes, we should hear some sound. Alright, so obviously this is a very bare bones structure, but you see that we can now create new templates, drag and drop them anywhere on the larger mouse area, and automatically have them connect into our ensemble at large very easily. So this is a really powerful framework. I hope some of y'all use it to do something interesting and upload it to the user library. Once again, this is Salamander Anagram with reaktortutorials.com. Thanks for watching.